the idea was to allow some time to have some open discussions about what might be, the major hurdles and issues that are facing each and one of these big efforts, like ESO's sample return mission, Jackson's, and the NATE's mission. Is there a way, sort of, for a small community like this to somehow improve the chances of these missions happening? So that was sort of one direction of open discussion that I was envisioning. Another one that we discussed was, there's specific opportunities that we could identify in addition to the ones that are already on the table for contributions to these missions. And of course, that's sort of a multiple layer question there. There has to be space agency funding, it has to fit within the strategic goals of agencies, but at the same time, it'd be helpful if we heard a little more about sort of how one might go about getting something to fly on one of these missions. That's sort of what I had in mind to ask.
Anybody have any great thoughts they want to lay out on the table?
Well, one thing in hearing these talks today, I was wondering about relative costs. I mean, we know about the Discovery programs, like 500 million, but the ESA mission, what kind of dollars were they looking at? Is that $1 billion mission? Was the Jackson mission, is that, what are those? Because that actually sort of gives us an idea of the spread in getting sample returns and, and compared to Discovery. So does then, like the Phase A for the ESA mission, see who presented that? Well, what kind of dollars were they talking about?
In terms of, I'd have to try and think off the top of my head, in terms of euros, we're probably around about that €1 billion mark. But in terms of dollars, then that's going to be 1.3, something like that. That's just an estimate ballpark, but it's of that kind of order of magnitude at the minute. It's going to be, certainly for an ESA mission, that's a big flagship mission. And the cost is certainly one of the parameters that is challenging at the minute. That's a significant cost for the agency to try and accommodate. Exactly.
Don't give me that face, Paul. What is that? In that order. I guess some of the American folks, what do you mean no, Tom? What the hell is that? Some of the American folks could think about in theory is, I guess we have a decadal survey, a mid-decadal update coming in theory, and then a full one, I don't know, some number of years after that. And if we think that this is important enough to add to the New Frontiers list of missions, a Phobos or Deimos sample return, then in theory the community would be able to maybe get that on the list, which right now it's not, and that might. It could cut both ways, right? I mean, at that level, it needn't. I assume it would, whether it would be a joint thing that the Mars and the thank you, that felt good. And the primitive bodies panels did together. I don't know, but it wouldn't have to just be one.
I was just going to say, aren't Phobos and Deimos officially an SBAG, not MEBAG or MEPAG? Sorry.
They sort of cross over both. Yeah. Okay. So they're in both purviews. It just depends on the context.
So joint custody, that's what you're saying?
Sort of joint, yeah, it's agreed joint custody. Yeah, so they fall under both. One of the things I was going to suggest is that I think a way of looking at to help these missions forward is realize there's multiple stakeholders. It's not just a science mission. That there's also interest from the human exploration and also from the resource utilization, identification, characterization side of things. So I think recognizing that a lot of the information that the science community is interested in is also the same type of information that the human exploration community is interested in. So not only with the what Andy said about the decadal survey, there's also interest in in having some human exploration targets. So I think having that put forward and that recognized, I think, will help sell some of these missions, so they'll dual use.
Yeah, so I was actually going to touch on exactly that point, but maybe we could ask Masaki and also Pascal Rosenblatt if human exploration planning, sort of precursor type of science acquisition, or resource utilization down the road was a factor at all in the design or thinking behind the mission, or was it strictly sample return for science in both of those cases? Pure science for MMX, pure science for sample return at ESA. Okay, so is that a consideration that could actually expand the potential scope of these missions, or is it more like a wall that's sort of predefined in the sense that thou shalt do science but nothing more on these missions? Saki?
I don't know how I should describe it, but it's... Could people use the mic?
Yeah, sorry. Sorry.
So, it sounds too, how do you call it? It sounds too much of a salesman if we say this is beneficial for human exploration. That's the situation my institute is in. My institute is a science institute within the space agency, and it's a science mission. We do know that there's linkage to the human exploration, of course, but if we ourselves start to mention it, it sounds like too much, I don't know, fishy or whatever you call it. And if you tell us there's that aspect in this science mission that will benefit us, then that makes our big brothers happy, maybe. But if we tell them, they think, oh, don't oversell your mission. That's what we think will happen. So that's why we stay decent. We still identify it as a pure science mission, and I think it is a good pure science mission. But at the same time, there's some, how do you say, fringing, aspect to this mission as well. I do know it, but we just cannot say it by ourselves.
Yes, yeah, so that's a good point. There are more talks about this tomorrow from Mike in particular. I also wanted to point out that there's a good, nice poster by Serena Dianega on the relevance of Phobos, of exploring Phobos and Deimos for MEPAG science goals. So that's addressing one of the things we talked about. Right, so I guess speaking personally, I will encourage you to mention the interest for human exploration to be included in the scope of all these missions. Yeah.
Just would like to add my opinion from the European side. So I'm just a scientist, I'm not an engineer at ESA, I'm not a manager at ESA, but well, I think that this Phobos and Periton is the priority. This is for science, of course, but there is some devices that will be developed and certainly will be used for a basis for future Mars and Periton mission, for example. But given the programmatic at ESA, we cannot say when it will be possible to be done. Of course, as a scientist, we hope that it will be the next step. But from a programmatic point of view, this is quite different. And especially this robotic program at ESA, this is not a mandatory program. So that there is only a contributor that wants to contribute. Okay, this is not a general contribution. And so this is why this is quite uncertain. to say when it will be possible to get certain mission. For example, after ExoMars 2020, we hope that it will be the Phobos sample return mission, but after, we don't know for the moment. And so, simply as a scientist, we have to wait what Programmatic will decide, but we are doing our best in order to put pressure to get faster in order to get this kind of mission, of course. But it is unfortunately not depending only on us.
Yeah. So as Paul was mentioning earlier, there's several communities that are really interested potentially in missions to Phobos and Deimos. And because the opportunities to go there are so rare in the end, we're talking about a sample return from JAXA in the late 2020s, Phobos sample return from ESA with a sample return in August of 2030. And Mike, I think tomorrow we'll be talking about humans going there potentially in the mid-2030s, presumably. So I mean, every one of these opportunities has to be somehow used to not just do the science at the core of these missions, but to opportunistically, at the very least, learn, help us retire strategic knowledge gaps. Jim.
There's arguably another twist that you could take on this. One of the nascent capabilities is the ability to launch beyond Earth orbit science missions from the International Space Station. When you can start launching a CubeSat or up to 100 kilograms, maybe even larger spacecraft as we get an enhanced airlock capabilities up to the International Space Station effectively in bubble pack, set it up and making use of a number of different trajectory insertion buses and the combination of alternate minimum energy trajectories as part of the NASA CubeQuest challenge. Our Team Alpha CubeSat is proposed to go out from the International Space Station, out past 4 million kilometers, cycle back, pass through the Earth-Sun L2, and end up in a resident orbit around the Moon. Using alternate minimum energy trajectories with our second-order calculations with Dr. Belbruno, we got the delta V requirement down by an order of magnitude. Okay, now there's a portion between that and the trajectory insertion bus that has to be done, and we have to build the thing. Okay, but there's some very interesting possibilities, and it ends up leveraging resources that are there. Okay, and it ends up building on a relationship both in terms of technology development and the manned spaceflight program that I think we could do a lot more with.
Again, just exploring lower cost options. So there have been a lot of, we kind of blew past discovery options, but I know there have been a number of ideas about flybys and impacts and collecting samples that would fit in a discovery envelope. Does anybody here who might have been related to one of those proposals want to talk about that?
He's standing behind you.
Carly? No.
Oh, well, but this was a question that Bill raised earlier. What can you do in a discovery class? And you can't do the kinds of things that was discussed in the JAXA mission or in the European mission, but you can do something. And are you familiar with the 80-20 rule, which is how much money you expend relative to how much science you get? And if you expend 20% of your resources and get 80% of the return, that's great. But to get 90% of the return, you have to spend, twice as much resources. So deciding, okay, how much is acceptable in terms of what you want to accomplish is this trade-off between small, medium, and big. And the mission that Jim was alluding to was a discovery class mission, which was pretty simple but very clever in its orbital dynamics, which was to kick off some soil from Phobos and Deimos using what we called a launcher, which is basically a trajectory, kick it off and sweep through the debris cloud and collect the grains. So you have grains from 5 different areas, similar to the Hayabusa 1. You know, not many, but some, and you knew what body they were from. And that's the 80%. You know, you can do a lot with 80%. But to get to the next level is more expensive and more sophisticated and has more return as well. So you can do some, but you got to accept that you're not going to do everything, but you're going to get the 80-20 rule.
Yeah, I think Aladdin was, of course, a great mission concept and got all but that last bit. I don't know if in this day and age, the way that discovery proposals are looking now, the things that for better or worse people expect out of discovery missions, I think from a strictly strategic point of view, the better option would be to try to get it into new frontiers where there are fewer things to compete with. Just looking statistically at that, and I don't know. I think it would be a tough sell for reviewers who are used to getting grams of material back to make the argument. You know, and someone's going to go, oh well, when Stardust collected stuff in aerogel, it came out really weird, and how do you know you're not affecting it with the collection? And so. And I was like 12 years old when that proposal came out, so I was not a reviewer. Which makes it more amazing since Carly was only 15 when she was the PI. So.
Is this turning into the Discovery Anonymous session? So, yeah, I worked with, I had the privilege of working with Butler Hine, actually, who was our project manager. Butler, for those of you who may not know, was the project manager / PI of LADI. So a really successful low-cost mission. So Butler was the project manager for this discovery proposal we worked on called PADME, Phobos and Deimos and Mars environment. So it was a multiple flyby mission. It was the idea was to try to see how much science you could get out of a very, very low-cost approach to getting to Mars and surveying Phobos and Deimos. And so we felt that we had a strong mission with international partners as well and industry partners, because it was a very low-cost mission, and meanwhile was able to achieve a quantum leap in our knowledge of Phobos and Deimos at the same time, without touching the surface of these bodies. So it was not a lander. It didn't even have to go into orbit around these bodies. It was just in orbit around Mars and flying by repeatedly Phobos and Deimos, and over time building up maps of composition of images. So anyway, it was not selected, and that's okay. But I truly believe that was sort of, in other words, that was sort of not the ideal approach to doing Phobos and Deimos science. It was, if the constraint is a discovery mission class budget, what can you do with that is really cost effective? And so several ideas were proposed in that context. But I truly believe that a proper sample return mission, like JAXA is putting together, and like ESA is putting together, is sort of the proper way to do Phobos and Deimos exploration, and to especially resolve the difficult challenge. I mean, the difficult science question of their origin. I mean, that's going to really require some return of representative samples of these two bodies ultimately to really get to the bottom of the story. So I think for just the science alone, a landed sample return mission is sort of really the way to go. And this is why I really like Andy's idea of somehow getting Phobos and Deimos on the radar of new frontiers. Okay, not to create yet another mission that's going to compete with MMX and Phobos sample return, but just because it's the type of mission, it's the class of mission I think would be right. But that said, it's also because this is the kind of mission that you would need to plan for human exploration. You know, to do an actual landed mission, some sample collection, understand the mechanical properties of the soil, the challenges of moving around. And so, in some sense, to me, a New Frontiers class mission is the right way to not just squarely address the science, but also, plan for humans.
Sure.
The New Frontiers program is so oversubscribed by fantastic science. You'll be 100 when this becomes reality, just because of the queue. And they're all great missions. They're all fantastic science. Now, the Discovery program isn't as healthy as we'd like, but there should be more opportunities. And if we can find a way of maybe doing 2 Phobos Deimos discovery missions, we might get there sooner. We just need to think creatively.
When it comes to budget, I'm very creative.
Well, one of the ways we can think creatively on Phobos Deimos missions is to recognize that Deimos is fundamentally easier to get to. And very much like, although there are differences, very much like Phobos. And the difference we might have is that you can get that one in a discovery envelope and actually get it done rather than holding out for Phobos and waiting for your turn in New Frontiers. So once again, the 80-20 rule faces you, and the difference in delta V between Deimos and Phobos is not an insignificant step.
I wanted to mention another possibility, since we're talking about possibilities, right? So, and I'm looking right at Paul Abel about this, right? Because I don't want to pronounce your name correctly. I'm sorry, Paul. No, but another option is that, Phobos and Deimos is a prospective target for human exploration. And there is precedent for the Human Exploration Program to fund something that helps them deal with their issues, namely that's the Lunar Reconnaissance Orbiter. So you could imagine a scenario where maybe if you want a sample return, you get some kind of tandem between SMD and HUMD to do something. Maybe they'll talk about that tomorrow, but I think that is, to me, that's a viable way forward rather than having to wait like late into the 2030s to try to do something. So.
Yeah, Mike Earnhardt from Johnson Space Center. Yeah, a couple comments. Within the Evolvable Mars campaign right now, we're looking at a whole bunch of different options, and politically, nobody's going to decide anything in the next few years. Having said that, it's not unreasonable to think that with the new administration that's sensible, they'll see that going to Mars surface via Phobos makes a lot of sense and is maybe affordable. And once that happens, then all these things change and get a lot better. I think it's all great stuff, and I'm very happy to see that the ESA and JAXA are pushing ahead on this. And if we decide to go there with humans on the way to Mars surface for real, then everything gets a whole lot easier. And we have plans that have precursor missions that leave assets there that are useful to the humans when we actually go there and so forth. And so there you start seeing these synergies that really start making these things possible. The other comment I was going to make is, have any of you talked with SpaceX about piggybacking things? Because my sense is, they're probably not going to get dragged into Mars surface in 2018, but they probably will in 2021, and then they'll probably follow that up with more and more stuff. And so I think that's a partnership that could be explored that'll probably be lower cost than the conventional development procurement process.
So getting back to Pascal's original idea of how we could suggest things to some of the planning missions that would help, Mike, not to put you back on the spotlight, but in terms of simple measurements that could be added to MMX or ESA mission, is there something that you've seen in precursor information that the human use of Phobos needs?
So we've been working with Paul and Steve Love and others, and we have, sketched out a precursor mission, and, all of it's great. I mean, we'll take anything we can get. For our mission, we actually want to have a lander that is a hopper that actually goes to all the regions we're planning to send humans to not only understand the science, but to look for hazards and so forth. And every time this thing hops, you actually learn something about the soil mechanics. And we've got, it's a six-legged hopper. It's got dust witness plates and penetrometers in the legs and can take pictures of each other and so forth. And it's very early, but we've sketched out the concepts and done some feasibility on the energetics and so forth. So that would be our ideal thing, where we actually have it there, and if it lasts a decade or so, then it would be available to the crew when we get there to even use as a robotic scout, so to speak. And so that's all great. Looking that, we'll take whatever we can get. I mean, but the soil mechanics is really important to us, because we're actually looking at using human pressurized hopper rover things, and if that looks like that's a complete bust, it would be nice to know that.
So just to follow up on what Mike said, I think one of the things that we get out of it from a human exploration standpoint is exactly what you said, is the geotechnical properties of the surface, is that surface interaction that is really important for human exploration, and the characterization of that surface, and how a spacecraft responds to that surface, or how the surface responds to that spacecraft interaction. And I think that's what we really are interested in. There's some other things that we're interested in too, in terms of the long-term radiation effects, if there's any shielding or anything like that. But a lot of the information that you're going to get from a science mission is really beneficial for human exploration. It's just a different way of looking at it. So particle size frequency distribution is really good for regolith studies. For us, it's really important to know if it's a nuisance or a hazard to our equipment and to our crew and other assets that we may deploy to the surface or near the surface. Plasma environments and things like that, as that's been mentioned by Bill, are really important as well. Again, from our standpoint of our equipment, if we do any sort of spacewalks, EVAs, all that stuff is going to be really, really important for us to understand.
Yeah, I was going to reiterate that point, that the adhesion properties of that regolith and how that would affect our suits and the cleaning of the suits, as well as the rest of the hardware, that's really important. And we'd love to know that now. In fact, in our concept precursor mission, we'd actually have one witness plate where we take our best guess on what the material was and what surface coatings would repel it, and take a look, and if it didn't work, we'd learn something, and if it did work, then we'd know, definitively that we've got a good solution in terms of the coatings.
So is something like your witness plates being a simple thing to add to a planned mission? Would that be a problem?
Yeah, absolutely. And a penetrometer for sure.
Yeah, and just to follow up on what Paul said and what Mike's talking about, is when humans go to visit terrestrial bodies in space, humans are clumsy, we're big, we require a lot of equipment, large scale versus, so basically interacting with the surface in a human-like way is beneficial. Typically with the science missions, it's very low-mass spacecraft, we're doing touch and goes. When we actually visit small bodies like Phobos and Deimos or asteroids with humans, we need to interact and get down in the soil and get dirty so we can understand how that really will affect humans.
So would it also be valuable to you to kind of reverse what a science mission would do, and instead of minimizing the plume on the surface, would it be valuable to have high thrust against the surface in order to see what the transport properties?
We would take whatever data we can get. And our plan with our hopper is, we would cut off our propellants and land on legs, so we would normally not contaminate the surface. And I'll talk about this more tomorrow, but it turns out with the mass of our pressurized excursion vehicle and outriggers, we can do EVA tasks easily up to 8 pounds of force, which is not that's a lot of task. And then for the higher force tasks, we would fire our up-firing thrusters to null those forces. And so we wouldn't be contaminating the surface very much.
Yeah, one of the things that you'd do is you'd like to get that type of information, but you don't want to compromise the science, right? So you want to do that after the sample. If you're going to be a sample return mission, you're going to do that at the end. So obviously when the sample return vehicle is lifting off from the surface, if there's a way of imaging that surface, imaging that effect of the ejecta that's being scattered by the plume, all that interaction, maybe even imaging where the sample was taken from, if there's any excavation on the landing legs, things like that. So having just basic cameras, very, very simple cameras that can just look at the interaction during the landing and actually the ascent, if there's any ascent from the surface, that would be really valuable. Again, it would be valuable for science because I think there are people here interested in the regulative properties, but it would also be very valuable from a human exploration perspective as well.
And so I have a question back to the science community. Is there a trade-off between sample return and having a more sophisticated lander with better instrumentation that can do more analysis and so forth? I don't have a strong opinion. I'm asking.
Yes.
Sample return's better?
Sample return is about 2 orders of magnitude better.
Just
I
asking
think
the
is the
question.
short answer. You just have to think about how you would automate the daily activities of a graduate student working with a 5,000
Yeah, no,
kilogram.
I saw all the gear there, but
Yeah.
It's just the question.
Yeah, it's very difficult to both automate these things, maintain calibration, and miniaturize these things.
Right.
And essentially, you're talking about being able to get huge amounts of sciences from microgram pieces of sample. No comparison.
Okay.
This might be end up not being a thing, but if you if it turns out to be in the plans to kind of really have your rocket plume go crazy on the surface of Phobos, it might be good to characterize the Phobos Doris beforehand, like to make sure that you didn't just create one, or and just it may not be a problem, but again, just thinking about all these things interconnect, and so it might be something that as a community we might want to have our ducks in a row before we start messing with some parts.
I think it would be really cool to make your own dust torus and watch it evolve. And of course, you check and see if there is one first, but then a little bit of enhancement. Blast a few hundred kilos out there.
If you feel like you need enhancement, then oh, get your mind. Oh, that's sick.
Okay, it's clearly time to adjourn for the day. So, yeah, thank you. Yeah, so Greg and I would like to thank all of you for a great day, from our perspective at least. And everybody's welcome and invited to chip in at Don Giovanni's on Castro Street. It's $25 per person. It's in cash, unfortunately, cash only. Okay, so I just work here. I didn't make the rules. So anyway, see you there from 6 p.m. to 8 p.m. With drinks and collations. And I'm told that somebody's going to bring some Mars vodka, which is sort of a special brand and brew of vodka. So, all right, got to try that.